I'm Chris's boss, so he has to be really nice to me. I'm also the thing that comes between you and lunch and going home. So I'm going to try and keep you awake, and I'm going to try and be quick so you can get your certificates and you get your lunch and maybe go have a beer or whatever it is you're going to do next. I'm not going to talk to you about anything like the last 2 weeks. Nothing like that at all. This is going to be something completely different, kind of Monty Python style. Let me start by asking you a question. How many of you here expect to have a career in science? Fantastic. Basically, was there anybody who didn't put their hand up? Yes, yes. Okay. Well, if I said that the ones who didn't put their hands up are the more realistic ones, because the truth is that only 4% of people who make it to their first postdoc end up with a career in science. Those are the actual realities. So what I'm going to talk to you a little bit about in the next 30, 45 minutes are some of the things you might need to know if you're going to take your technical skills and take your ambitions and take your drive and your energy, because to get here you guys have to be amazing, and apply them in other fields. And I'm going to talk about a few key skills. So mainly I'm going to talk about innovation and the broad concept of innovation. And let's start at why is innovation important. So I'm Chris's boss, and that guy with the beard is my boss. So he's the head of Esrin. And the guy without the beard in the top left-hand corner from where you're, right-hand corner from where you're sitting is his boss. But actually, the really interesting quote is the guy down on the bottom, a guy called Steve Jurvetson, VC investor in Planet. So he's a guy who's put up some of his own money to build this company called Planet, which is one of these new space Earth observation companies. And his observation about space and Earth observation is that compared to other industries, he has never seen such an enormous margin for improvement. He's used to people coming to him with pitches to take away his money and burn it that offer like 10 times improvement. But in space, he thinks that typically they're seeing people come along with like 1,000 times improvement or 10,000 times improvement. This is kind of how moribund the space industry has become over the last 40 years. Big, long, slow planning, doing things that take, we've got a launch coming in a couple of weeks. It might be next week, actually, that they started working on 22 years ago. And, so on these kind of life cycles, the world moves on by the time you're finished. So innovation is about kind of keeping on top of the world. And so what I'm going to cover, quick canter, what do we mean by innovation? How do we go from ideas or research through to innovations, things that are actually innovations? And last of all, I'm going to talk to you about the most important skill for successful innovation. And I'm going to make you do some exercises. And not only am I going to make you do some exercise, I'm going to pick on people and ask them to stand up and read out their exercise. I'm really sorry. So this is the interactive bit, and I'm going to keep you awake. So this is your first exercise. I'd like you to start. Have you all got laptops or bits of paper or whatever to hand? Yes? So I'd like you to take 2 minutes, and I'm going to time it, to write 80 to maybe 120 words, something like 100 words that explain your research. And as I say, I'm going to time it. One minute 30. You can put your hand up if you're done, if we finish early. 1 minute. So we're looking for one paragraph, a couple of sentences, maybe 3 sentences that describes your research, what you're working on. Okay, last 30 seconds. You look like you're ready. Who else is ready? Everybody ready? Yeah? Okay. Volunteer. You're the closest. Give us your 100 words on your research.
Oh. I repeat many times. I wrote, I use multispectral data for detecting large fossils exposed on desertic surface. I also contribute to the creation of a database regarding paleodata in order to estimate extinct animal distribution and their interaction with climatic change and human spread.
Great, thank you very much. Could I have one more victim? Sorry, volunteer.
Volunteer?
Volunteer. Gentlemen, we've had a lady. Oh, okay.
Oh,
okay. No, that's good, that's good, that's good.
So I use a mix of field measurements and satellite monitoring in order to investigate greenhouse gas emissions from organic wetland soils in order to provide the best possible estimate for the UK government to report emissions to the United Nations Framework Convention on Climate Change.
Great, thank you. Okay.
Do we want one more or not?
No, that'll do for now, otherwise we'll be here all day. So, I'm going to take you through a similar exercise a couple more times, and you'll see why at the end. So, okay, what's innovation? Somebody tell me, what is innovation? Anyone, put your hand up. Marcus, tell me, what is innovation?
Oh, that's a tough one. I was thinking about this the other day, so I don't have a clear answer.
Okay, too slow. Another one. Somebody else, somebody tell me, what is innovation?
Identifying a challenge and using a novel method to solve it.
Okay, that's an interesting definition. Somebody else?
A changing point of view.
Sorry?
Changing point of view over things.
That's interesting. Yeah, actually, we'll come back to those kind of themes later. One more, last one.
I would say thinking outside the box and just figuring out something new, as broad as that.
Some new way of doing things. Okay. So we have 4 examples of what is innovation. You know, you ask someone the question, what is innovation? And actually, a lot of people do exactly what Marcus did, which is, hang on, I need to think about that. What actually is it? But it's a term that's used all the time, and it's a term that's used interchangeably for being a good thing. Mostly, when people think of innovations, they think of really, big things. Artificial intelligence, reusable rockets, the wheel. Here's Fred Flintstone with his wheel, or the iPhone, or people think of really big stuff that has made a huge, big difference in society. However, that's just one category of innovations, because the things we tend to think of when we think of innovations are things that are disruptive innovations, right? They're things that come along and create a big change in a market or in society or in science or in some discipline or whatever. And they're often either a radical new idea that's been built up through loads and loads of research, or they're a combination of techniques that have been developed in one discipline and being brought over into another discipline. There's actually quite a typical way of developing really radical new ideas. Take something that works in one place and apply it in another place where it might fit. So that's one kind of innovation. But what about these examples? I mean, would you consider Pepsi to be an innovation? How about, Android phones? Are they an innovation? Actually, strictly speaking, they are innovations. What they are is incremental innovations. And they are just as important as big disruptive ones. The disruptive ones don't come along so often. I think the research suggests that today it takes about 15 years to develop a new innovation that will come along and disrupt a market, do something that's really, really different. So most of the innovation that goes on in the world is actually kind of incremental innovation. It's something that takes an idea and moves it along a little bit to explore a new market or slightly improve something or make something go faster or cost less money or whatever. So essentially, innovation then is not just about disruption. It's an improvement that can be new to the world. It could be a really radical new thing like the theory of relativity or reusable rockets, or it can be new to a market. It might be a product that you're introducing to a new market for the first time, or it might just be something that's new to the organization that you're working in or the field you're working in. So, right now at the moment in the Phi Lab, we're introducing SharePoint. This doesn't sound like a particularly radical innovation, but actually this is an innovation for us because it's new to the team, it's new to the folks who are involved in it, and it's something that will allow us to share files and that kind of stuff kind of more easily. There are actually a bunch of definitions out there of what innovation is, and they're actually really formal definitions. Probably the earliest formal definition, the earliest formal definition that I know of was an Austrian economist called Joseph Schumpeter. And he defined there being 5 types of innovation, which are new products, new methods of production, new sources of supply, opening of new markets, or new ways of organizing a business. Likewise, here in Frascati, the OECD produces this thing called the Frascati Manual. OECD, who knows what the OECD is? Cooperation and Development. Organization for Economic Cooperation and Development. So it's a big kind of, it's a kind of economic equivalent of ESA. So it's about promoting exchange of economics ideas and how to run countries better and how to run businesses better by learning from each other using economics. And they have this manual that they update every now and again that's all about innovation. It's called the Frascati Manual, conveniently enough. I guess they probably put up with the food in the Villa Tuscolana just the way you do. And what they say is an innovation is the implementation of a new or significantly improved product, good, or service, process, a new marketing method, or a new organizational method. So there are actually really quite formal definitions of what an innovation is. But there's one really important point here. There's a really important point that I want you to grasp, and it's the second most important point of this next, maybe there's 20, 25 minutes left. So an innovation is not a new idea, right? An innovation is not about developing a new way of doing something that's better or cheaper or faster or radically different or potentially disruptive. An innovation is an idea that has actually been adopted, that gets introduced to a market or a space of learning or some new environment or an organization or whatever, and it gets adopted. You can have all the ideas in the world, but if nobody takes any interest in them, they're not innovations. Unless you can get your ideas across to other people, they are not innovations. For this reason, very few new ideas are successful innovations. Now, it depends on which academic you read. So you can read papers that will tell you that 1 in 20 innovations are successful. You'll read other papers that will tell you 1 in 100 innovations are successful. If you look at a funder like Y Combinator, the success of the companies that they fund is kind of in the 0.1% or even lower. If you go to any incubator, the vast majority of companies that are trying to set up in incubators fail. And what the Americans will tell you is if you're setting up a business, you actually, they think you haven't actually earned your stripes until you've had 3 failed businesses. because that's what it takes to learn to actually innovate and get your ideas and your products adopted. But anyway, why are economists so interested in innovation? Why innovate at all? Well, the first reason is efficiency. Innovation drives efficiency. Here's the amazing example of Moore's Law that has been played out for the last, well, it's kind of getting on for nearly 60 years now, since it was first talked about. And, the gradual incremental improvement of the number of transistors that you can squash onto an integrated circuit has completely transformed our society. And it's an enabling infrastructure for lots of other stuff, like AI, like our phones, like communications, all this kind of thing. So it drives efficiency. Secondly, because of obsolescence. Because you have competitors, your ideas will become obsolete. And who knows what this is? Yay! I'm amazed, actually. I'm actually amazed that you know what this is. I learned to program on a computer that had a floppy drive that was this size, literally that size, and it held 20 megabytes. 1979, PDP 1134. So there's obsolescence and there's competition. So innovation is about surviving in a competitive environment, and we basically live in a capitalist world for all intents and purposes, and capitalism is all about competition. I mean, Joseph Schumpeter, as well as coming up with the ideas of a definition of innovation, the thing he talked about a lot was creative destruction. How actually how businesses becoming obsolete and dying off is actually essential for progress. Whether or not you agree with that is a slightly different matter, because actually if you're in the business that's about to get closed down because you're obsolete and you and 500 of your mates are about to lose their jobs, this doesn't feel so good for society. But the capitalists, the macroeconomists say this is a good thing. And what all the evidence suggests is that innovation is absolutely central to growth. And that's both at a macroeconomic level and a microeconomic level. So macroeconomics talks about how economies work, whole countries work, collections of countries work, the world works, the world economy works. Microeconomics is about the economics of the individual business. There's a really well-established link between the amount that a country or an organization invests in R&D, in their innovation, and how quickly that company grows, or that country grows. There are different estimates. So like there's this PwC thing that I put up that says that the most innovative companies are expect to grow twice as fast as the average and something like 3 times as fast as the least innovative companies. I've seen other stuff that says 1/3 of all growth comes from innovation. So without innovation, effectively, we're in a world that moves more slowly and in which the wealth of society and the wealth of us as individuals improves much more slowly. So, next question is, how do we get from research into innovation? How do we get from having a great idea into having a great idea that isn't one of the 95% or the 99% or the 99.9% of ideas that actually didn't pass muster, didn't turn out to be adopted by anyone or considered to be useful by anyone? And it's actually a pretty simple idea. How you get from having a good idea to having a good innovation is you basically ask people if your idea is a good one, and if it's not, you adjust your idea so that it becomes more good. It's really that simple. And the people you might start with are your customers, or you might start with colleagues who are working in the engineering department and will tell you, well, this will not work or that work for that reason or another. But for the most part, organizations have huge, big processes that are based around doing market research, finding business partners, getting investment, all this kind of stuff, in a highly structured approach to taking ideas from what are just basic concepts through to something that really, really works in the marketplace. Because what you want to do in the end is get to a place where you've got something that is being adopted by other people. Prototyping is critical for this. And testing the prototype on real customers is critical for this. But say you're building a rocket. You know, how long have we been working on building Ariane 6? Anyone want to give me a number? Marcus, do you know?
Yes, 18 years.
18 years. Okay, that's quite a long time. And how long has SpaceX been working on reusable rockets? Anyone know? Well, they started doing experiments, I guess, about 5-6 years ago. And the first things that they started putting up and down automatically. So a lot of this development of big ideas can actually be really slow. And it's because it's slow, it's expensive. And because it's slow and because so many ideas fail, it's expensive. So big organizations and governments, also in their big innovation planning processes, have usually set all kinds of criteria that they use to define, to test whether or not an idea is likely to turn into innovation, whether it's the kind of thing that's likely to be adopted by others. And here on the right-hand side of the screen, you see that here's research done by 4 different management consulting firms, where they went out and they looked at what the attributes were for a successful innovation. What did you need to do? What were the things that meant an innovation became really successful? And the most interesting thing about this, for me, is when you look at this table, right down the very bottom, with only one tick, is that it's your new idea has come into a favorable competitive environment. It's not that it needs to be the first idea in this particular arena. It really doesn't. I mean, look at Pepsi. Pepsi is 40% of the market compared to Coke being 60% or something like that. The most important attributes of successful innovations are actually that you can do them well and that there's something that somebody needs. There's also, quite critically, the question of can it go big? That last one is the absolutely critical screening test for the likes of Y Combinator and the VC funds. Because they have such incredibly high failure rates in the companies that they support and they incubate, they have to focus on innovations that have the potential to scale, not to be €1 million businesses or €10 million businesses, but businesses that can be $1 billion or 10 billion euros. That's what they're looking for. They're looking for things that can go really, really big. But actually, this research is actually quite old. I think this is from something like a book I found from 1995, some years ago. So this stuff, these approaches to innovation have been around for quite a long time. So when you're developing ideas, you're kind of looking to the future and you're trying to decide what's the market going to be by the time I get this product ready or launch this idea into the world, and building towards this future concept. There's a bit of a problem with this, though. You recognize this movie, right? Who recognizes the movie? Tell me what it is. Blade Runner, the original Blade Runner. Okay. So what's the really weird thing that's pictured in this? So this was their picture of what the world would look like now in 2018. And I think this was, 1981, I think Blade Runner was? I remember seeing it in the cinema. So what do you see here that's kind of weird? Somebody, anyone? They're making a comeback. Only Dentine survived. No, come on. What else? It's really obvious. Telephone booth. So they thought, Ridley Scott and co. thought in 1981 that by now we would have flying cars, but we'd be driving in our flying car down to the ground to make a phone call on the telephone booth, right? The problem with kind of great big plans and doing research for something you're going to launch in 15 years' time, and remember, the average for disruptive innovation is 15 years. The problem is that 15 years is a very, very long way away. And by then, things are likely not to be what you expect. So another approach to developing ideas was born out of the software movement in the, well, not the software industry, and it became a movement. It became what's called the Agile movement. And Agile is about, instead of doing lots and lots and lots of market research in the beginning and having a great big plan and spending years doing engineering, and then 8 years down the line you build a prototype, and then you maybe take it to do some user testing in focus groups, and then you refine it, and so on and so forth. Agile is about saying, how can we get to a prototype in a month? And sit down with some users, or maybe 3 months or something like that. How can you get to your minimum viable product as quickly as humanly possible? And it only has to be the minimum product. It has to be something that somebody somewhere is prepared to pay for. But the idea is to cut out all the bureaucracy and slow research that has existed previously in product development. And this, this was the typical way of doing product development. The reason it cost so much was it took so long. So Agile is about cutting out all the slowness. It's about being as simple as possible. There are 12 things in the Agile manifesto, and the one I love the most is simplicity. The art of maximizing the amount of work not done is essential. Agile is about taking ideas and applying exactly the same strictures to them, but doing it quickly, and in particular, by bringing people together with lots of different skills and making them work on something together and involving the users maybe not on day 1, but certainly on day 30, the people who you want to get the idea out to. Now, there are lots of innovations out there. There's some really interesting, I'll mention in a second some of the innovations that are coming in our arena, Earth observation. But, innovation is of itself a huge industry, and there are big organizations out there like Gartner who've developed theories for how innovations evolve. And the Gartner hype cycle is a really interesting idea, because what they do is they capture in this curve the idea that in the beginning, you get people who are trying to get investment for their idea. And so they hype it up as much as possible. So it's like the first .com boom back in the late 90s, early noughties, when all you had to do to get a couple of $1 million from a VC was add .com to your company name. Most of those businesses went bust. But now, actually, the internet and internet-based services and all this kind of stuff rules the world. Can somebody give me another example of a similar thing that's been on the hype cycle recently? That's been at that stage of all you got to do is say you're doing it, and you get like $1 million. Another one? The one I really like is blockchain. So literally, there are companies out there. There was something like I think they were a soft drinks manufacturer in the UK, who said, right, we're setting up a blockchain investment program for soft drinks, and their share price jumped 4 times overnight. So ideas come along, they get really hyped up in the beginning. It all tends to go horribly wrong at a certain point, at which point the real work comes in of actually turning them into viable ideas that can be deployed in society. And Gartner tracked this, and you can see some really interesting stuff along here. So Gartner would argue that blockchain is actually on the way down from the hype cycle right now. And certainly the discussions that we have in the Phi Lab are kind of things like, okay, blockchain, is that really useful for Earth observation? It's coming down the other side. AI is also coming down the other side, but there's some really interesting things coming up the other side, which are heading into the world of hype. So stuff like the brain-computer interfaces and quantum computing and edge computing and all this kind of stuff. I would say, you mentioned drones? I think drones actually, I think they're doing pretty well as it is. There are lots of companies out there using drones for really, really successful businesses and successful new applications. I mean, the military have been doing it for years. I mean, the military are busy killing people with drones, left, right, and center. But, you know, mining companies are using drones. Police are starting to use drones. You know, so basically, ideas start with hype, crash, and then evolve into viable innovations. And we see lots of this stuff right now. And some of these things are still at the point in space, I think, of being hype, and because nobody's really tried them yet or done something that really tests them and pushes them. And some of them are really obvious, fantastic innovations like reusable rockets or CubeSats or nanosats. But the one that I think is the most interesting and the most exciting emerging trend in space are the last two on the slide here on the bottom right. So it's the advent of the Silicon Valley investors and the VC investors coming along and pushing into the space arena and bringing with them the approach of agile development. You know, so does anyone know Spire? A company called Spire? Gentleman at the back. Yes, you know it. Tell us about Spire.
They have a plant in Glasgow, and they produce probably one of the most number of CubeSats in the world.
Exactly. Spire have, the last count I saw, I checked it last night, was 81, but I know that's not up to date because we had Peter Platzer here a few weeks ago who runs the company, and he said he's launched since that number. So they are putting out new satellites for Earth observation. I think the launch cycle is every 4 months. They're launching 4 new nanosats, and on every one they're trying something new, and they're doing a new product, or they might be accessing a new market. You know, they started by doing weather forecasting. Now they're going into ship detection and ship location, this kind of stuff. So I think the most exciting innovation for me in space is not necessarily quantum computing or nanosats or any of that kind of thing. It's that we're now in an era where it's viable for ideas to come along and be developed on like a 6-month life cycle. You're not talking about 10 years or 15 years or 20 years. It's about agility. Right, second exercise. So 2 minutes to write about 100 words again that explains your research to an investor. I'll set the timer. I'm not sure, do you need 2 minutes? Will 1 minute do? Yes, no? Okay, we'll go with 2 minutes. So imagine you were going off to Silicon Valley. You've had a great idea. You've spent all your savings and all of your parents' savings and your grandparents' savings that they've lent to you on developing your idea. You've been through 4 agile development cycles, so the company's like maybe a year old. How do you sell your idea to an investor? What you work on right now? One minute. Okay, in 30 seconds, I'm going to start picking victims. Okay, 10 seconds. Is there anyone here who'd actually like to read out their description of their work to an investor? Thanks.
Okay. So there is a huge lack of data in the developing world, which includes key emerging markets like the BRICS, so Russia, India, China, etc. Traditional data collection methods such as household surveys and censuses are expensive and provide infrequent data. Satellites have the potential to provide consistent, reliable, and often real-time data. So investors, developers, governments, countries, corporations would be interested in paying money for this data type.
Great. Isn't that nice and clear? Somebody else volunteer with their magnum opus in 100 words. Gentleman who's closest to you in the white T-shirt. How about you? Come on.
I would say something like my research is focused on beach morphodynamics, namely on understanding the interaction between wave structures and sediments. And nowadays, as the climate changes, we got more storms, the sea level is rising. So the knowledge on these processes is very important so we can develop integrated coastal protection structures and schemes.
Great. That's really good. So what I'm actually going to talk to you about now in the last 10 minutes is what I think is the most important skill for successful innovation. And it's why I've been making you do the exercises. Can anybody give me anyone want to guess what the most important skill is for successful innovation? Wild guess. Somebody. Anyone.
Thinking out of the box.
See, I disagree. Because remember we come back to that list of boring management consultancy studies, and they say that your idea doesn't have to exist in a really good and competitive environment. There can be lots of other things just like your idea there already. Marcus.
Ability to convince people.
Being able to convince people. Anybody else?
Perseverance.
Perseverance. Actually, that's a really important one, but I don't think it's the most important one. One more? Usability. Okay. Okay. Come on, just shout out loud. Don't put your hand up. Okay. Well, so I think one person, maybe two people got it right.
The ability to know what people need and are willing to pay for.
That's critical. But there's a skill that you need before that to make that work, and that skill is communication. So in science and engineering and technical disciplines generally, we're used to having really well-educated audiences. We're used to having people with huge background knowledge and information. We're used to people who understand all the acronyms we use. We're used to conveying our ideas by standing in front of a room and giving slide after slide after slide of equations, right? We're used to working with people who take the evidence we present and reason about it, and they might tear it to pieces, but they'll reason about it in a really in a logical way, and they'll help you tear your ideas apart. The slight problem is that is not how the rest of the world works. Okay? It really is not how the rest of the world works. So I don't know the statistics for Europe, but in the UK, 70% of people do not understand percentages. So like 7 out of 10 people in the UK would not understand that sentence. Right? You know? Sorry? Yeah. It's a similar proportion. A similar proportion cannot understand a sentence that's longer than 23 words. You know, and even at 23 words, they're starting to get lost. And by the time you've put in the third comma and the parenthesis and the equation, completely forget it. This is a graph of the minimum length of TV commercials over the last 50 years. I mean, people's attention spans have gone down. People don't pay attention anymore. They're too busy looking at their phones. They don't have time to sit there and try and work out what your equation is or what the acronym stands for. And not only that, not only do people not have the background knowledge, not only do people not have the skills to understand longer sentences, but actually a lot of people, most of the decision making we actually make is made not on the basis of evidence, but on the basis of emotion and feeling. rational approaches. Has anyone here ever heard of Daniel Kahneman and I think it's Anatoly Tversky? Kahneman, behavioral economics was their huge innovation. So Kahneman and Tversky won the Nobel Prize for economics, I think. I'm not sure when they won the Nobel Prize, but they came up with the work in the 70s. And what they found actually was that the fundamental presumption of economics that people are rational is deeply wrong, right? The vast majority of people make their decisions on the basis not of the slow way of thinking that you do using evidence and rationality, but through rapid decision-making processes that we've evolved from living up trees and running away from lions. And they make us make really non-evidence-based decisions. So let me give you an example. I'll talk about this example in a second, actually, but there's a better example. If you walk along, you can do an experiment where you ask someone to pick a ball out of a bin, and if the ball, say in the first part of the experiment, all the balls have the number 6 written on them. But you ask them just to pick out a random ball, and they think it's random, but they all have 6 written on them. And then you can hold up a bottle of champagne and ask them, how much would you pay for this bottle of champagne? And if the number written on the ball says 6, lots and lots and lots and lots of people will say, I'd pay about €6 for that. If you write the number 40 on the balls and you ask them the same question, they pick out the ball, they look at the number 40, and you ask them, how much would you pay for this bottle of champagne? And they will say, oh, I'd pay about €40 for that. Exactly the same bottle of champagne. We are not as rational as we think we are. We are really not deeply reasoning creatures. Here's another example. This is something I actually worked on a few years ago. We were doing some research into how to effectively communicate with the public about air pollution. How do you get the message across as government to tell people that air pollution is bad for them? Now, we've got 3 statements here. About 10% of deaths in London are attributable to air pollution. Second one, the main health outcomes of air pollution are cardiovascular disease, strokes, and cancer. Third one, air pollution includes exhaust gases, bits of brakes and tires, and ground up stuff on the road. This coats the inside of your lungs and travels to other organs in your body. So can I ask, who would be most persuaded that air pollution is bad for you by 10% of deaths being attributable to air pollution? Okay, great. And who would be most persuaded by the main health outcomes of air pollution are cardiovascular disease, strokes, and cancer? A few people. How about air pollution coats the inside of your lungs and travels to other organs in your body and is made out of tires and stuff ground up on the ground? Who would be convinced by that? So what's really interesting is here we are in a group of scientists, and I'd say maybe half the people in the room put their hand up for the first one. And it's a terrifying statistic, and it's probably an underestimate as well. It's probably much higher than this. But the general public, if you want to get the message across for the general public, first of all, 70% of them don't understand the 10%, right? Okay? The bit that gets people is this idea of bits of tires and stuff on the road coating the inside of their lungs and going into their blood system. This completely freaks people out. That's what gets their attention. Not the idea that, there's a 1 in 10 chance that their kids might die of breathing this stuff. We are deeply emotional creatures. We are not rational. And in essence, you have to communicate when you're communicating to other people who aren't scientists, who aren't technical. And I would say even when you're talking to people who are scientific or technical, you have to use all the tools at your disposal. Don't assume that people know what you're talking about. Try and keep things clear. In my experience, technical people are really bad at communication. We are. I'm a physicist by background. And it's a long story between how I got there and how I got here. But in my experience, technical people are really, really bad at communication. And I'm going to give you an example that I dealt with this week at work in the field lab. So this is a project that we've just funded. It's a great project. It's an absolutely fantastic project, right? And we asked them, we'd like to do a press release on it or a blog piece to go out on Twitter and go up on our website. And we asked them, could you give us a couple of paragraphs that describe the work you're doing? And we got this, okay? So I'm going to give you a minute, and I'm going to ask you if you can tell me what this thing is going to do. This was going to be the press release, right? From the engineers who we've just funded. Anyone? Can anyone tell me what this project is going to do? Anyone? Sorry? It's definitely something to do with data access, right? Anybody else? Anyone got a vague idea what this is real? I am not making this up. This is, I copied and pasted it from a document this morning from one of our fundees. Anybody else want to take a wild idea? Wild guess? Eventually, after the 5th version, we got to the food industry and farmers growing potatoes and other crops will soon save money by using data collected from satellites. Our natural tendency as scientists and engineers is to use jargon and buzzwords and presume that people understand what we're talking about, and they don't. So you have to customize what you're saying to your audience, and you have to put it in language that they'll understand, so that you can test your idea, so that you can improve your idea, so that you can take it through Agile or whatever. So I think the next slide is the last exercise. Okay. So I'd like you to take 2 minutes, and I'm going to pick on some of the same people again, maybe, which is a little bit naughty. But I'd like you to take a couple of minutes to write about 100 words that explain your research. Sorry, I forgot to ask, does anybody have a grandmother who's got a PhD in physics? Anyone? No, okay, good. Keep going. You explain what you do to your grandmother in a way that she will understand. One minute. 1 minute to make sense for your grandmother. "30 seconds. And I'm going to start asking for volunteers. Here we've got a volunteer. Here's another volunteer.
Since I deal with resolution announcement, my thought was to ask to tell my grandmothers like to put some glasses on the satellite.
There we go. That's not bad, is it? Somebody else.
So basically this really happened. I had to explain my grandma what I was doing at work. So I said to her, I'm using my computer to look at images. These images are coming from the sky. And in the sky, we have these little boxes that take in pictures. So it's like a phone, but it's bigger, so.
Great, great. Anybody else? So I picked on you earlier. I'm going to pick on you again. Come on. Explain to your granny what the stuff about the waves.
I would say something like, you know, Granny, that beach we used to go, that now there's no beach because the sea is coming to the town. Well, I'm studying how to make better structures so that the sand gets back on the beach and we can enjoy it.
Absolutely awesome. And actually, if you'd said that to the investor, they would have been far more likely to give you the money, wouldn't they? Wouldn't they? So, I mean, to communicate with the vast majority of people, you've got to be really clear about what you're saying. And I don't think this lesson is lost on talking to other scientists too, because I think half the time we sit there in lectures and we're looking at this stuff and we're going, what the hell is going on here? You know, if you want to explain to people, then explain to people in language they will understand. Use terminology they'll understand. You know, customize your message to your audience. I mean, linguists have a really formal process that they describe about this. Language is the process of encoding ideas in such a way that they can be decoded by other people. You know, so think of the decoding that the other person has to do. There's a wonderful quote from Blaise Pascal, which I absolutely love. "I'm sorry I wrote you such a long letter. I didn't have time to write you a short one." Writing stuff, communicating well takes work. It's a skill you have to develop. And I think this is my last point to you. I would urge you, for the rest of your scientific career and outside of science, and for any time you are dealing with other people, develop your communication skills. I think the ability to communicate your ideas will allow you to take even bad ideas and get people to take them on board. For product innovation or innovation in general, it's absolutely essential. But say you're one of the lucky 4% who stay in science. I mean, to me, the reason we're screwed over climate change is because we explained the problem so badly. We did a really, really bad job of explaining the problem to the world. You know, when people asked us, oh, is climate change real? They said, oh, well, it's quite uncertain. You know, what? These skills are as important to you in explaining the huge challenges that we face in the world that you're working on as they are in product development. Work on your communication skills. Use them in talking to scientists. You know, don't mystify stuff. And remember, innovation is not about having a new idea. Innovation is about getting other people to take your idea on board or buy it or adopt it or use the process or technique or whatever. And essential to that is using good communication skills. Okay, that's me. Thank you very much.
So, are there any questions on that highly inspiring talk about innovation? There must be some burning questions.
They want their lunch. They've got to catch a plane at 4:30.
Well, if no one has a... Oh, there's a question at the back. Okay.
One of the things I'm doing right now is trying to develop a master's course that has a strong entrepreneurial angle to it and focuses on the Sustainable Development Goals. And I remember we were having a discussion with somebody from SCAT, and he was like, well, the SDGs are humanitarian. How can you make a business out of that? So that's what I would want to ask you. How can you make a business out of using space data for, you know, the Sustainable Development Goals, which seem to be humanitarian in nature?
Yeah, you've got to find the angle that somebody is going to pay for somewhere. You know, that's a tricky question, but it's not unsolvable. I mean, I have spent chunks of my career trying to persuade people, for example, that it would be worthwhile to get to monitor carbon dioxide from space. This was long before it was really possible to measure the differences relatively easily. But the interesting thing was that you could find people, say, in the insurance industry or investors who were really interested to understand if it would be possible to see if a company was cheating on its CO2 emissions. The critical thing is finding the right customer. It's often the thing that takes the longest time. But if you can't communicate your idea to them in the first place, it doesn't matter what customer you find. But the answer is to find the right customer. There will be somebody somewhere, hopefully, who can make a buck out of you executing the Sustainable Development Goals.
So we all know that citizen science came as a great help for involving general public informing them how things are changing. And so do you think there is anything like something like that, or is there potential to expand it even more, or something parallel that we could do to reach, like to give whatever scientific knowledge that we are acquiring in simplistic terms to general public to make them see, and not giving any jargons and statistical numbers, but...
The thing is, citizen science and effective science communication is really effort intensive, right? So the problem with citizen science works, but the problem with citizen science is that for the most part it works for the people who are the citizens who are involved in the science. If you want to talk to the whole population, you can't kind of do it's difficult to, well, maybe we can now in the era of everyone having smartphone apps and all the rest. But it is effective, but it's quite intensive. And that's why I would actually urge everyone in this room to develop the skills to explain their ideas, because the effort, you know, we've got to explain to the whole world what we're doing and why it's important and why they're going to keep funding us. I mean, honestly, we live, you know, there are leaders of many world countries now who are kind of crazy. And, you know, you ask them about climate change and they say, oh, that's not real, you know, right when we're having a global heat wave. It's, so, yes, citizen science is valuable, but it doesn't diminish the need for the necessity for all of us to be able to communicate effectively.
Thank
you. You talk about the kind of the idea of the agile market, like to kind of drive things to move a bit quicker. Do you think that ESA and other space organizations are feeling the pressure of that with designing missions?
Totally.
And do you think
but that's what our lab is set up. Yeah, totally. And I mean, and it's right. It's great. You know, our job in the lab, where Chris and I work, is to bring these methods and these ideas into the agency. You know, this is use of these methods as a model for what we could become. Moving quickly to answers. Moving quickly to fail is as important. You know, why spend 3 years doing your PhD and discovering at the end of 3 years that your idea was wrong? Why not try and find a way to solve that problem in the first 3 months and then move on to something that's more exciting and that you can publish some really exciting papers about? So it's, I mean, NASA right now looks kind of crazy for investing in the Space Launch System. They really do. You know, it keeps getting pushed off into the future. We have pretty good logic for why we're not investing in reusable launchers, but it does look kind of tough in the environment. But at the same time, Europe's in a pretty good place on stuff like CubeSats and so forth. We're better than the Americans are on this stuff. And part of our remit is to try and capitalize on that.
Right, so I'd be interested to know how what you think about squaring the circle of the problems of communicating things so that they sound interesting, sound exciting, and still managing to communicate the potential uncertainties. So like the reports that were out, was it this week or last week, I'm losing track of time, but on the runaway warming and climate catastrophes.
Yeah.
Because if you say that and it's big and exciting and people listen and it doesn't happen, then you get fake news.
Absolutely right. And I mean, the example I gave you earlier on air pollution, I worked, you know, I'm an atmospheric scientist, worked for years on air pollution, and I had very limited knowledge, well, I had some knowledge of marketing and stuff, but I worked with some communications professionals who were experienced in doing focus groups and so forth, and I was astonished by the kind of stuff we found about what works for people. What are the triggers that is likely to take an idea and turn it into a big idea or for it to go viral. I think, again, it comes back to the point of why it's important to have these ideas in your head of how to communicate effectively. Are you going to say something that will allow people either to conclude that what you've said is untrue or uncertain, or they don't need to worry about it, because a lot of the time news is so shocking and so awful that actually people's natural emotional instinct is to find a way to avoid it. You know, and we all do this. You know, the last thing we ever want is to think about the fact that we've got an exam in 3 months' time or whatever. You'd rather go down the pub or what. Yeah. So think about what you're saying and don't speak off the cuff. Think about what you say. Craft very carefully what you say. Don't use language that allows people to imagine that something is not true, and carefully use language that manages to be true and to convey the idea. But for complex ideas, this can be really difficult. I mean, that's why we were commissioned to do the research on understanding communications about air pollution. I mean, we've lost the pass on climate change. We lost that a really long time ago when we got big international news organizations like the BBC running around the place saying that climate change was uncertain. I mean, in the 2000s. So we're not traditionally trained in communication skills as scientists, but you've got to do it. You have to. Otherwise you'll be misunderstood. And that's how you end up with these press releases that are just completely wrong. I mean, there's also pressure too. Most funding bodies now ask for evidence of impact. And there's a tendency of researchers to kind of blow that out of proportion, frankly. It's important to be honest, but it's important not to confuse scientific language with real-world language. Yeah, I think that's quite a good point to finish that on.
Okay. Could there come a point when the only way for scientists to actually have much influence is to move directly into politics?
Well, a bunch of scientists did that over the years. Margaret Thatcher was a scientist. Jimmy Carter was a physicist. Angela Merkel's a physicist. What do you call him? Mikhail Gorbachev was a physicist. Certainly in the case of Thatcher, it was actually critical to her. Crispin Tickell, who was, I think, the US ambassador to Washington at the time, was involved in the negotiations on the early versions of UNFCCC. And he sat down with her and they had a science conversation about climate change. And he was able to convince her this was something to take seriously. So, little known fact, Margaret Thatcher was really serious about climate change. So the presence of scientists in politics certainly makes a difference, but it doesn't necessarily automatically mean that they'll be great politicians. I guess if they learn the communication skills, you've got to have communication skills to be a politician, but it's not necessarily a panacea. Did I answer your question? I'm not sure you did that. So I would say yes, absolutely. Scientists should go into politics, but they need to learn the right language to use in order to be effective. Okay.
I was just wondering, could you explain a bit more about the Phi Lab and like what it actually does? Is it only for postdocs, or is there seed funding available for related startups or some sort of an incubator program?
Okay, so what's our motto, Chris?
Our motto, I think, our motto is just to succeed fast and fail fast. Okay.
That's one of our mottos. So our motto actually at the moment is "Hello World." What our motto stands for is welcoming new ideas into the agency and new methods and new techniques. And it also stands for the fact that we want to welcome people into the lab. So if you want to come and spend time in the lab, let me or Chris know. We will host you here. We're not yet in a position where we can fund you to come and stay, but we're working on it. If you're brilliant, or if you want to contribute to something that we have planned. We have funding schemes, so we have 2 significant funding schemes, one of which we spend Yves Louis' money, which is great, on exploring new ideas, and that includes work on citizen science and AI and lots of other projects like this. We have another funding scheme to help businesses incubate their ideas, and it's supposed to give them access to money pretty quickly. I think in theory we're supposed to get them an initial yes or no within a month, which for ESA is unheard of. Although so far I'm discovering that it can take over a month to get all the signatures for that once you've actually agreed to give them the money. But so the FEE Lab is here to start applying Agile principles and new technologies within the agency, so the agency can learn how to use these, and the agency can learn how to disseminate them throughout our industry and use them more effectively in science. That is what we are there for. We have funding streams. We have we'll be advertising 6 new fellowships. I think we're expecting to do it around September. We expect to have a complement of about 20 staff, including industrial fellows from Airbus and a few other places by the end of next year. And we have quite significant funding streams that have been contributed by member states to help make these ideas fly and get people to try things even if they fail. I mean, as Chris said, actually, one of our principles is to fail fast, to try things and see if they work or if they don't work, and if we need to switch to something else. Did I answer your question? Good.
Okay. Are there any other questions? One more question. Okay.
Could you go back to this slide with nanosatellite or CubeSat?
Sure.
I think we have the CubeSat, nanosat. In several years, maybe we'll have a picosat, because we know the background for Earth observation, synthetic aperture radar, and others. But what do you think to create bigger satellite with higher amount of power and to try to see what is inside the Earth with the radars, active microwave? I know the penetration depth, others, the dependence with the between the penetration depth and carrier frequency of the wavelength, it's okay. But if there is a aim of this or a need?
That's not on our work plan, I have to say, but I think it's the kind of thing that building much bigger orbital platforms is obviously becoming possible now because of the bigger launchers that are available. It didn't fail, it just didn't last quite as long as was expected. So anybody else?
Okay.
Last question.
So for like quite large organizations such as ESA and other large scientific bodies, do you think applying the Agile strategy will kind of require a bit more of a structural change within the organization to kind of avoid the bureaucracy of these huge like organizations where things tend to move quite slowly as compared to in startups where they can get things running very quickly?
Science is super conservative. Engineering is super conservative. And in the space industry, we've traditionally been super conservative because we don't want things to blow up on the launch pad. The companies that are being really successful now are the ones who care a bit less whether or not it blows up on the launch pad, because they're going to try another one in a month's time anyway. And okay, it'll cost them money, but it's not quite the same pain. So yes, absolutely we have to change. I think there will be a natural evolution, effectively, and whether or not government-based organizations can ever learn to be Y Combinators, I doubt that, because it's not the way government is set up. But what we can do is the sort of stuff like creating venture capital funds using public money to help support industries that want to invest and move quickly. And I think that's the direction it's kind of moving in now. And I think that's probably the most promising approach at a large scale right now.
Any other questions? I don't want to put you off. You know, we have an hour for the closing, so we have plenty of time.
Yeah, I was just thinking, because you're not independent, kind of. I mean, if there's a chain of knowledge starting from education and then research and then these whole large projects. So applying this agile rapid development in one part of it without having some background, like starting from, I don't know, university or maybe even sooner, and then in research, and then
it will just slow down if this development is applied to the last part of the chain.
It's funny, you get some of these investors, like Bill Gates and Peter Thiel, have both argued that people shouldn't go to university, because they both dropped out, and they think everyone is like them. Actually, most of us aren't really like them. Most of us aren't going to read 30 books a week and spend 80 hours a week working and that kind of stuff. There are people who argue for that kind of thing, but I'm not sure I'd like to get on a train that had been built by a bunch of engineers who hadn't been to university, who had just kind of learned it from books or whatever. Yes. Sorry?
Yeah, I'm not saying that.
Okay.
I'm just saying that. I'm not saying that. I'm just saying the rapid development to be applied to the other processes, not to dismiss the processes.
Sorry, okay. And I think that the key point that I may not have emphasized enough in talking about Agile is the idea of bringing lots of different skills together in one place in each development step. So rather than having all the engineers go off into a dark room and work on something for a month and then come back, you have engineers working with designers, working with people who deal with the customers, who do design, that kind of stuff. So Agile is about actually bringing lots more skills to the problem rather than narrowing it down.
Okay. Anyone else? Okay. Okay, well, thank you very much for that.
Welcome.
Yeah, that was,
Safe home.